So welcome back to the next part of this course. So here we'll discuss the case studies to conduct life cycle assessment. The case study one is the quantitative case study in which we have the quantitative data. It was actually a study conducted by Franklin Associates in 1992. They conducted a study on the diapers which were used for the kids. So we had two kinds of diapers. One is disposable, another is cloth, that is reusable. So this was a study that was conducted in 1992. So just to have zest of what is life cycle assessment, we can conduct this study, but do not trust the results. The results are just to have the feel that how the value life cycle assessment happens. But these days the diapers problem is intensified. So the disposable diaper is a big problem here. So we'll see the results what they came out with in this study. So we have two types of cloth diapers based on the way they are laundered. Number one is home laundered. Number two is commercially laundered. Home laundered is the diapers are washed at homes only. Commercial laundering is when the diapers are washed in the central stations that collect it from the households and then wash them. So we have some data here. It was observed by the data collected by Franklin Associate people that the cloth diaper is used about 10 times a day, like when the kid soils the diaper, and the disposable diaper is used 5 times a day. This is cloth versus disposable. We have two types of cloth diapers here. So in a year, the child can use anywhere between 3100 to 3700 cloth diapers to 3700, and this number in the case of disposable diapers was 1800 to 2900. So this is the frequency of use. This is an average frequency, and this is the numbers. See what I am doing, I am trying to see the quantitative data. Number one is goal and scope. The goal is to identify the embodied energy in manufacture of diaper and in the use of diaper. So my goal here is, like I said, raw material and manufacturing, and it reaches end user, and it is then disposed. Before disposal, whatever happens, the diapers are manufactured and they are sent to the user. User is using that, processing them, that is in washing them or throwing it away. So what is the energy that is consumed in this case? This is we are focusing on. This is our goal. And scope may be comparison or maybe improvement. The first scope I'll put it as comparison only, comparison between disposable and cloth diapers. So the scope is comparison. So the goal is the boundary which I have put here. So this was the first step. So there are two different kinds of cloth diapers which are distinguished based on the way they are laundered. Home and commercial. So it was found that 85% of cloth diapers were washed at home. So I would put washing here. There is no washing here. 85% were washed at home and remaining 50% were commercially washed, commercially laundered. And the significant differences lie between two: the water volume, the washing technique, and also the uses per diaper directly impact the solid and waterborne waste as well energy efficiency. So we'll see that data that is obtained here. So what is this chart representing? It is representing the megajoule of energy per child per year that is consumed for these diapers, for disposable diapers and for cloth diapers. It was observed that 6900 megajoules of energy was consumed in case of disposable diapers, out of which the energy can be divided into two forms here, three forms actually: feedstock and process energy, washing energy, and miscellaneous energy. So feedstock and process energy is the raw material and manufacturing, for which that is used for manufacture the cloth or disposable diapers. Then washing energy is energy that is used for cloth diapers only, because washing happens here. So you can see the light green color is absent in disposable diapers. So we have this light green color in here only for cloth diapers. So this was 85%, about 86% was the feedstock energy, and the remaining 14% was about was this, and remaining 14% was the miscellaneous energy. So this difference was about 1000 joules. So we had 5900 here, 5900 megajoules. So in case of cloth diapers which are home laundered, the energy was primarily from the laundering process. The total energy of the home laundered diaper is about 9600 megajoules. 85%, that is 8200 megajoules, is used in laundering process. This is 85%, that is washing only. While commercially laundered or commercially washed diapers used 8600 megajoules of energy. This is 8600 megajoules of energy, and the maximum part here again is the washing energy only. So which is about 65% of energy here is for laundering. I'll put it in a clear way. This is 85%, this is 65%. However, the energy, if you see the overall embodied energy in case of cloth diaper is higher. Cloth diapers is higher than the disposable diapers. Because the laundering process is also energy intensive here. So the cloth diapers which are home laundered, the energy consumed is higher, which are commercially laundered, the energy consumed is lesser. So based on this assessment, if this is the only criteria, we can say that we can select the disposable diapers as an option. So because the energy consumed, embodied energy, that is only 6900 joules here. So let me put the caption or the title for this illustration here. It is actually the total energy used in 1 year for each diaper. So in the difference between the home and commercially laundered cloth diaper is the amount of water that is consumed. So the next illustration here tells the cubic meters of the solid waste that is produced per child per year. So it is volume of solid waste. So before talking about solid waste, I would like to put here that it was also found that for the cloth diapers which are home and commercially laundered, there was difference between the amount of water that was consumed. So it was about 34,000 liters of water for the home laundered diapers per child per year. And the number in case of the commercially laundered diapers was 21,000 liters. So you can see that the energy which is consumed and the water that is consumed in case of clothes diapers which are home laundered is high. So the next aspect here is the solid waste. So solid waste is divided into two groups: industrial and post-consumer. Industrial waste is like if I said raw material, manufacturing, and whatever distribution is there, and here is end user. So this waste is industrial waste, and after end user, when we dispose of, that is post consumer. So this is post consumer. So the two diapers produce nearly the same amount of industrial and post consumer solid waste, differing slightly because of the commercial diapers are thrown out early, and the cloth diapers produced 160 kgs, while disposable diapers produced 260 kgs of solid waste. So it is industrial and post consumer. The industrial waste is the waste that is produced due to the processing, raw material production, and the manufacturing trimmings. You can put it here. Production, then trimmings of the cloth, then ash from electricity. This was industrial waste. Then the post disposal or post consumer, which is the disposal waste, that refers to the substances thrown out by diaper itself. That is the diaper, then packaging, that is also thrown away, then child waste. So the two cloth diaper produces nearly the same amount of the waste here. The only thing is that the commercially laundered diapers produce slightly higher waste here. So the waste here is measured based upon the landfills, that is the volume of the landfill that is consumed. That is this is the cubic meters per, this is the volume of solid waste or volume of solid waste in landfills. To make it more clear here, this is water here, water consumption in case of these two diapers, cloth home laundered and commercially laundered. And it was found that the disposable diapers occupied the most landfill space, that is, it was about 0.4 meter squares per child per year. This is disposable diaper. And the cloth diapers, for the cloth diapers was about 0.24, and it was 0.21. Besides this solid waste, there were waterborne waste, then air waste. The waterborne waste actually they comes from raw material production, irrigation of cotton fields, laundering steps, sewage treatment. So air waste can also be called as atmospheric waste, which also come from the industry as well as home. So this is the impact analysis. Actually, the previous slide also was the same thing. We, in the first step, what we did, we identified the goal and we fixed the boundary, and then we put the scope. Scope was comparison, like in the initial stages we put the scope as pen comparison. So the next step is inventory analysis, that we are just doing, and also we are doing the impact analysis. And we have evaluated different kinds of figures here, like waterborne waste. The figures are also available. They were also available in the study. The figures was about, it was for waterborne waste for the disposable diapers was about 1.2 kg, and for the home laundered it was 10.2 kg, and for commercially laundered cloth diaper it was about 9.6 kg. So we obtained all these figures. You can follow this study by Franklin Associate to see the more details. Franklin Associates in 1992. So this is the comparison between two. So the impact analysis and we did evaluation. So what do we do next? Could we, next fifth step I would put here, could we suggest some improvement? So before suggesting the improvement, in the evaluation, what comparison we can say? Based upon the energy analysis, you might have seen that energy consumed, embodied energy in the disposable diapers was less. Based upon the energy analysis, one can choose disposable diapers. Based upon this waste production, one can choose the clothes diapers which are home laundered. And see, all these different types of data are collected and the rating is given to specific type of data. Like we can prioritize energy consumption or we can prioritize the waste that is produced. Based on that, we can select the product which is better. Like there is a trade-off of place. You can say there is a transition in here. So you can see that this is a transient behavior. Like one is waste is higher for disposable diaper, but energy consumption is lesser. So we need to have the balance between them. So what improvements could we suggest? One can suggest that, okay, in place of using water to wash the diapers, one can air dry them. One can use sun to dry them, and we can use certain other alternative materials. For instance, bamboo clothing are there, which are highly biodegradable clothing, also that is soft as well. And these types of suggestions could be given. So next I have a qualitative case study. So for qualitative study, I have brought a product that is the coffee cup that we use. So these are three kinds of cups. This is the plastic cup, simple plastic cup that is bent from the top here. So this is a plastic cup. We have styrofoam cup that is also a disposable cup that is used to, that is like use and throw thing. And we have the paper cup. This is made of paper. So you have three materials: styrofoam, plastic and paper. So these cups are disposable and they are used to consume tea or coffee. So I'll like to draw the comparison between them. We do not have some quantitative data in them. Quantitative data is what is like cost we do have, but what is the energy? We only know that, okay, this is for energy, that is energy conservation for this specific cup is higher, this is low. So in place of quantitative data, what we can do? Let me first put the different kinds of the cups here, the product which I have chosen. The product here is coffee cup. Okay, so I can choose plastic, then paper and styrofoam. Also, I have the general cup which we use. This is the ceramic cup. The ceramic cup that is reusable. This is not the disposable cup. So we just use water to wash it, water and detergent, and reuse this again and again. The bigger difference is, one thing is this is reusable. Second thing is the cost is higher. That cup are like they get 2 or 3 cups in 1 rupee. Those cups. This cup is costing maybe 50 rupees, maybe 100, 200 rupees, like that. So let us try to make a comparison and try to see how qualitative life cycle assessment can be conducted broadly here. So we have paper, plastic, styrofoam, and we have certain criteria here. Number one is energy conservation. Energy conservation means how much is energy conserved. It is not energy consumed. Please mind it. This is the opposite of that. Energy consumed is how much is embodied energy consumed. This is energy conservation. How much is energy conservation possible with while we use a specific product. So the product number 1 plastic, product number 2 and product number 3 styrofoam, The energy conservation, if I put them into the scale here, which has rating from 1 to 5, I put moderate at 3 and I put high here, low here, and very low and very high in comparison. So in comparison to the paper and styrofoam, I can even put the ceramic cup here, ceramic cup, or maybe we can choose the glass or something like that, which is reusable. The plastic, in case of plastics, the energy conservation is high. In case of paper, the energy conservation is low. In case of styrofoam, the energy conservation is very low. In case of ceramics, the energy conservation is low. So why this difference? The plastic industry, in the plastic manufacturing, I could say even the paper manufacturing, paper is actually water intensive process, it is energy intensive process, so energy conservation is less here. And in case of styrofoam, also the energy conservation is less here. In case of plastics, less energy is consumed. So less energy is consumed, that is energy conservation is put high here. In case of ceramics also, based on the types of process, the way this is, the energy is consumed. So the next criteria I can put here is, so let me divide it into the columns. So next criteria I can put here is the waste conservation as well. So waste conservation is not a very good term here, but we can just use it. Okay, the waste conservation here, by waste conservation I means if we throw the paper, paper is biodegradable. So paper is biodegradable, that means it is inducing less impact on environment. So waste conservation is higher. So I am taking only the positive points here. Waste conservation is higher in case of paper, and in other cases I can put low, low and low. Ceramic, water and plastic. And next is water conservation. Water conservation is the water that is used to in production process, water that is used in disposable or washing maybe. So as I said, paper is a water intensive process, so water conservation is low in case of paper, and it is moderate in case of plastic. It is high in case of styrofoam because very less water is used. So in case of ceramics, in case of ceramic cup, because it is reusable cup, so the water is used to wash it again and again. So here water conservation can be put low. The next is recyclability. In case of recyclability, I can say the plastic is completely recyclable. The paper, however, if the cup is used, however, this sheet paper sector can be reused, they can be recycled, and the recycled notebooks, all those things are available. But when cup is consumed, the recyclability is not very much possible, or when it is actually possible, but not very much used here. And in case of styrofoam, the recyclability is not possible. So recyclability for plastic, completely recyclability is there, so we can put it very high. Recyclability is very high for plastic. For the paper, I can put low. For styrofoam, I can put moderate, and for ceramics, recyclability would be again moderate. So I'm just putting the broader idea. Sometimes the data is not completely available, the rough idea or rough information is available, so you can use this in the qualitative scale here. So next criteria, we can pick certain criteria here. We can pick air pollution, we can pick the water pollution as is considered in water conservation as well. We can pick air pollution, we can put the landfill or solid pollution. These criteria, let me put air pollution here. air pollution. So I'll put the positive points here. For air pollution for plastic is very less, that means it is good, so I'll put high. It is not air pollution high here, it is that the air pollution, the savings I can put in air pollution is high, or less air pollution is produced in case of plastics. In case of paper, the air pollution is moderate. Why moderate? I'll just tell you. In case of styrofoam, no air pollution. In case of ceramic, no air pollution. The paper has some skin. This paper has some skin. After some time, this skin actually moves to air. It is transferred to air. So because of this, I have just put moderate, not high, not low. So just moderate air pollution can happen with paper kind of cup. So next is landfill. That is a solid waste. So here I can also put landfill savings, because the one which consumes less cubic meters of land to fill in, so that would be rated higher. So landfill in case of plastics is low, in case of papers is very low. Why very low? I'll just tell. And this is low, this is high. Because I have put landfill for papers very low, because paper is something that is biodegradable. So biodegradable, by biodegradable means it would take a few months for converting the paper to the soil itself. So it is for the plastic, it takes millions of years, so that is not biodegradable. So that is why the landfill savings is I have put very low. However, very less amount of land is or let me change this to moderate. This is moderate for plastic and styrofoam, and for ceramics the volume is higher, so landfill is higher. So another point I can consider the cost or cost savings here. Cost savings. The plastic, paper and styrofoam are two, as I said, in 1 rupee we can buy 3 cups, in 1 rupee we can buy 4 cups of plastic, and so on. Like this is a very low cost elements here. So in these cases, in these 3 cups, I can put the cost savings high. But this is an maybe 100 rupees cup, so I can put the cost saving maybe as very low. So this is the qualitative information which I have obtained or which I have identified for these types of the product, that is the coffee cup here. So the first step is goal and scope. So I have defined the goal, my boundary. Boundary is the energy conservation to landfill, all those things are considered. And scope is the comparison between 4 cups, plastic, paper, styrofoam and ceramic. Okay. Second step is inventory analysis. The inventory analysis and impact analysis, we are considering water conservation, waste conservation, energy conservation, air pollution, landfill savings, all those things are considered here. So the next step is evaluation. Now for evaluation, what we can do, one can choose any of, or one can prioritize any of these criteria. For instance, if I prioritize energy conservation, I can even rate these from 1 to 5. I said okay, I gave better weight or higher weight to energy conservation, then maybe to air pollution, okay, then to cost savings, that is not important for me. I considered this is not important for me, I put it 1. So this is the rating, 1, 4, I can put some 3 here, some 3 here again, some 2 here, 4 here. So what happens, how do we calculate? This is actually a kind of AHP, an analytical hierarchical process. We do the comparison like this one. Now next what I will do, I have these ratings H, L, M, VH, H, M and H, this is high, low. I will give rating to this. For very high, because it is energy conservation, waste conservation, water conservation, recyclability, savings in air pollution, savings in landfill and savings in cost. So, very high means that we are on the positive side. So, I will put here 5 for very high, 4 for high, 3 for moderate, 2 for low and 1 for very low. What actually I am going to do? I am going to obtain a score for all these 4 options. To obtain that score, I will first rate these. Okay. For H, the rating is 4. For low, the rating is 2, medium is 3, very high is 5, high is 4, medium is 3, then high is 4, then for paper I have 2 for low, 4 for the high, 2 for low, 2 for low, 3 for medium, 1 for very low and 4 for high. And for styrofoam kind of the cup, I have 1 for very low, 2 for low, 4 for high, 3 for medium, 4 for high, then 3 for medium, 4 for high. Then for this ceramic, I have 2, 2, 2 for the lows and 3 for medium, 4 here and 1 for very low. Now, this is the rating based upon the conservation of the resources, energy, waste, water, recyclability, so on. Now, I already have the impact here, the impact of the criteria that I am using to select the product here. Now, I will need to have the values here, the total contribution of energy conservation in selecting plastic material. Total contribution would be, I select 5 from here, 5 and 4 from here, 5 into 4, this is 4, this equal to 20. So, I will put value 20 here. Similarly, I will pick 4 from here and 2 from here, this is 4 into 2, this is equal to 8. I will put the contribution to be 8. So, I will calculate all these values, this 3 for the medium, this 3 into 2 is 6, 5 into 3 15, 4 into 4 16, 3 into 3 is 9, 4 into 1 is 4, then 2 into 5 is 10, 4 into 4 is 16, 2 into 2 is 4, then 2 into 3 is 6, 3 into 4 is 12, 1 into 3 is 1, then 4 into 1 is 4. Similarly, I will put the values here. This value comes to be 5 into 1 5, 8, 8, 9, 16, 9 and 4. This is 10, 8, 4, 9, 16, 12 and 1. Now, while adding these light green color numbers which are the contribution, I can get a total score here. For the plastic it will be 20 plus 8, 28 plus 6, 34 plus 15, 49 plus 16 is 65 plus 9 is 74 plus 4 is 78. This score comes down to 78. Then for the paper is 10 plus 6, 26 plus 4, 30 plus 6, 36 plus 12, 48 plus 1, 49 plus 4, 53. Similarly, for this is 5, 8, 8, 9, 16, 9, 4, it comes to 61. For this 10, 8, 4, 9, 16, 12 and 1, it is 60. So, I have got these scores. Based upon these scores, I can rank them, I can put ranks here. This is rank 1, that is the plastic cup is rank 1, the styrofoam cup is rank 2, the ceramic cup is rank 3, and if I draw a scree plot, I can see these two values are too close, 61 and 60 are too close here. So, and this is rank 4 here, okay. These are the ranks here. So, I will select the plastic cup here. Now, what if I change the criteria? If I change the criteria to something else, let me say I put some different weightage here in place of cost. I put here rate 10. It will change the whole criteria while putting different weights. Now, it has to be very careful calculation and careful selection of the weights for these criteria. So, a team, people who are experts in energy conservation, or people who are experts in manufacturing, and who also have a comprehensive knowledge of what is more important for green manufacturing of the product, they are required to put these weights here, because these are the main contributors, because these are the main points which are contributing to give this score. So, based on this qualitative criteria, I can select this cup. This is star and this is selected. So, this was all in life cycle assessment. So, next I have a task for you people. You please choose a product like you did in the previous sessions. You select a product, then select a few types, like I chose the cup. You can choose some pen. You can choose a pencil with the plastic body and lead core. You can choose a pencil with wooden body and lead core, and you can select any kind of product. Select the product and try to conduct the similar qualitative life cycle assessment. For this, you have to ponder over the kinds of impacts that will produce. You can select a few criteria. Do not select all these. You can select energy, water, solid waste, and then you select the cost, maybe one of the criteria. So, just select 3 or 4 criteria and put the weights in between. Put the qualitative values here, high, medium, low, and try to find the score in the same way which I did. So, in the next lecture, we'll meet. I'll discuss about the sustainability framework and the kinds of green manufacturing systems, the elements of green manufacturing systems. Thank you.